Dear colleagues, dear conference organizers, thank you for the opportunity to present a report. Dear colleagues, we bring to attention reports on the topic data mining in the healthcare system, based on the machine learning model developed in the Microsoft Azure Machine Learning Studio. The authors of the study are Klochko, Gurevych, Viktor Mikhailович Nagayev, Людмила Юрьевна Dudorova, and Tatiana Petrovna Zuziak. This report presents data mining, which is based on the regression analysis and machine learning. We developed and applied machine learning model, which includes the regression models, Bayesian linear, artificial neural network, decision tree, decision forest, and linear regressions. In the process of applying this machine learning model, using the mentioned algorithms, the regression models were constructed and their comparative analysis was performed. The results were analyzed. In today's world, healthcare costs are rising rapidly, primarily due to epidemic problem caused by coronavirus disease, COVID-19, demand for quality healthcare, aging population, increasing number of people suffering from chronic diseases with long-term disease, etc. Please look at the scheme. The benchmarks of this system are the quality of medical services and their costs, which is important for the patient, not their volume. The components that are the basis for the transformation of the healthcare system are computer science, payments, benchmarking of research and tools, logistics of medical services. The results of the measurement are used to adapt health services for the populations for the path of the patient care. Based on the improving the quality of the health services, reducing their costs, rather than increasing the amount of care. The aim of the study is to data mining of the healthcare system based on the model machine learning developed Microsoft Azure Machine Learning Studio. This includes models Bayesian linear regression, neural network regression, decision tree regression, and decision forest regression. We developed the regression modules using Microsoft Azure Machine Learning. In this study, we use data from the medical cost personal data sets, which are publicly available on the Kaggle platform. Please look table number 1. The dataset is presented in CSV format. It consists of 7 columns, 1338 rows. Data were tested for multilinearity. It is established that multilinearity is absent. The dataset contains the fields described in table 2. We conduct the study of the impact on charges. Is individual medical expenses incurred under health insurance? Predictors. Age is age of the main beneficiary. Sex of the insurance contract. BMI is body mass index. Children is number of children on health insurance. Number of dependents. Smoking is smoking. Region is the residential area of residence in USA. As a target to determine the charges Y. As a regressions, we choose X1 age, X2 sex, X3 BMI, X4 children, X5 smoker, X6 region. The scheme of the machine learning model based on the regression construction algorithm is presented in figures. Let's discuss describe the model presents continuous. The dataset model, you need to load the data for the further process. The deep metadata block allows you to edit metadata by selecting columns from the dataset. The split data model divides the rows of the dataset using the settings into two different sets for training and model testing. Modules Bayesian linear regression, neural network regression, boosted decision tree regression, linear regression, decision forest regression, provides the creation of regression modules using the above algorithms. Training of the regression modules is implemented using the training model block on the training dataset. To develop regression modules are tested using the school model block on the test part of the data. The evaluate model evaluates the developed regression modules using standard indicators: mean absolute error, mean squared error, relative absolute error, squared negative error, coefficient of determination. To execute R script, you need the responsible for the executing the R script of machine learning experiment in order to extract any performance indicators of the model. Using the add rows block allows you to add a set of rows from the input dataset to the end another dataset. It was used by use in order to obtain comparative statistics of performance indicators of the developed regression models and to provide convenient data analysis. Let's analyze the obtained results of construction of regression models on the basis of comparative statistics. According to the average absolute error, the close to the actual result data prediction was built using the algorithm's decision forest regression. 2628.5 and boosted decision tree regression 3074.87. The worst result for this indicator 8608.14 was obtained using the neural network regression algorithms. High average absolute error at about the same level were obtained as a result of the construction of linear regression 4035 and Bayesian linear regression 4033.11. The obtained mean square error values also indicate the superiority of the decision forest regression. 4891.34 boosted decision tree regression 2688.5 alphas. As previously estimated, the values of linear regression 5875.64, Bayesian linear regression 5870.81 are higher than the experimental RMSE values of the decision forest regression and boosted decision tree regression algorithms, and are approximately at the same level. The worst value is the result of the neural network regression 11,604.3 among the data estimate of the RMSE indicator. In terms of the relative absolute error and relative squared error, the probability of estimation of regression model algorithms remains the same as in two previous results. It should be noted that the worst indicators of the neural network regression relative absolute error equals 0.98 and relative squared error equals 1. Which characterizes the approximation of the error value to the average value of the result trials. value of the coefficient of discrimination was obtained by testing the model built on the algorithm's decision force regression at 3.51%, slightly lower than the value of the coefficient discrimination obtained by the algorithm-boosted decision tree regression at 2.5%. Models obtained using linear regression, Bayesian linear regression are also adequate, as their coefficient determination is 74.75% and 75.8%, respectively. The value of the coefficient of determination, approximately 0.002, test a model built on the algorithm neural network regression indicates that the model is inadequate. The model that is closest to the actual data, the machine learning model, built on the algorithm decision force regression. Slightly lower values were obtained in the process of building regression models using the linear regression and Bayesian linear regression algorithms. The model built using the neural network regression algorithms is inadequate and unusable. This result indicates that the application of this algorithm requires additional setting, careful primary preparation of data sets. The main goal of building an integrated information digital healthcare system focused on people is to support the fundamental model of palliative care and innovative value-oriented model of healthcare. Thus, as a result of the analysis of data on the basis of methods of mathematical statistics and machine learning, the following is done. A model of machine learning system was developed, which includes the regression analysis model based on Bayesian linear regression, typical neural network, decision tree, decision forest, and linear regression. The model built on the algorithm decision forest regression is determined to be most suitable for use. Coefficient of determination model testing equals 83.51%. The presented methods can serve as a basis for the strategic development of new areas of medical data processing and decision making in this area. The obtained result already determine some areas of future research in the application of data mining method in the healthcare system, namely the use of machine learning system of clustering, classification, detection, anomalies, and more. Dear colleagues, the report is out. Thank you for your attention.